So we're going to kick off our discussion talking about the network layer of the TCP/IP model by talking about the address resolution protocol, better known as the ARP protocol. So the ARP protocol has one simple purpose, and like its name implies, its purpose is to resolve addresses, specifically to resolve an IP address to a MAC address when we're talking about ARP. There's also a reverse ARP protocol, which is a sub-protocol of the ARP protocol. And what that does is that will resolve a MAC address to an IP address. So the exact opposite of ARP. In one instance, you're going to have an IP address and you don't know the MAC address. So you use the ARP protocol to find out what that MAC address is. And if you know the MAC address, but not the IP address, you would use reverse ARP. So its purpose is to resolve IP addresses and MAC addresses. Now, the command for the ARP protocol to find out what your ARP cache is in your operating system is going to be the same in Windows, Linux, and Mac. And the command is ARP -A. And we'll do a live demo after this video. So let's go ahead and let's actually take a look at how ARP works. And then we'll come back to this slide and we'll take a look at the output from the 3 different operating systems. So let's walk through a very simple example of why we would need ARP. So let's say that we have system number 1, and system 1 wants to communicate with system number 2. And we'll say that system number 1 is new to the network. So system number 1 knows system number 2's IP address, but it doesn't know system number 2's MAC address. So what does it need to do? It needs to send an ARP request. So it's going to send off an ARP request, which we see right here. And what an ARP request is, it's a broadcast message. So when you have a broadcast message, it goes out to every single device on that LAN. So let's say that we had a cable connected here, a cable connected here, another one connected here, and another one connected here. Well, that ARP request is going to go out to every single device on the network. And each device on the network is going to inspect the ARP request, and only the system with the IP address in which system number 1 is trying to communicate with will respond, which will be system number 2. So system number 2 will say, hey, I'm the system you're looking for. My IP address is 192.168.1.15. You know what? Here you go. Here's my MAC address. My MAC address is this one right here. Go ahead, put it in your ARP table. And the next time that you need to communicate me, now you have it. So when you send something to the switch is going to look in its MAC address table and send it only to me. So that's how the ARP protocol works. And if it was reverse ARP, it would just be flipped around. We would have the MAC address, but we wouldn't know the IP address. So we would send a reverse ARP request, and it would just be the opposite in terms of the addresses that we're requesting. Now, jumping back to the first slide, let's now take a look at the ARP command to see our ARP cache table in our operating system. So what happens when you send out ARP requests is that your operating system is going to put the responses into an ARP table, which is your ARP cache. That way, it doesn't have to send out ARP requests all the time. So once it knows the associated MAC addresses and IP addresses, it puts it into the operating system. So it simply looks in there. And then if it doesn't know it, then it sends out an ARP request. But if it knows it, it uses the table. So the command for seeing that is very simple. It is ARP-A, which we see up here. And also in these systems, the specific outputs are going to be very similar as well. And the command is the same. So over here on the left, this is Windows. We have command prompt. And these two over here, this is going to be Linux at the top and Mac OS at the bottom. They both use what is called terminal, and the output is very similar because they're built on a similar platform. So let's start over here on the right talking about Linux and Mac OS. So the command is going to be ARP-A. So you'll notice up here, I typed in ARP-A, and it shows the IP address of 10.0.2.1 has the following MAC address. So this is going to be the MAC address of that IP address. And then also down here with the MAC output, so we have the command at the top, ARP-A. We have 3 different entries. We have 10.0.2.2, 10.0.2.255, and 224.0.0.251. Each one is going to show its associated MAC address, and then also shows the actual Ethernet interface that it is on. So if you have multiple different network adapters, they may be on different Ethernet interfaces. Now let's take a look at the Windows output. The Windows is a little different. So with the Windows output, over here on the left, it says internet address. So that is going to be our IP address. And then right here where it says physical address, this is going to be the associated MAC address. And then simply what this means is that this was based off of an ARP command. You can actually statically type in an entry into your ARP table. So if you wanted to manually assign a physical address to an IP address and vice versa, you could do so. But if you're simply just using ARP commands, it's going to show up as dynamic. So you're going to notice that it has multiple different entries, and these are the associated IP and MAC address entries. So that is the ARP command, the address resolution protocol. It's pretty basic and pretty straightforward. What we're going to do in the next video is we'll do a quick live demonstration. I'll show you how to get to terminal, and I'll show you how to get to command prompt, and I'll show you how to run the ARP command. So thanks for watching. If you have any questions, please let me know. If not, I'll see you at the next video. Take care.